So in today's class, we'll definitely be able to move further. But before that, let's just do a recap on what we learned yesterday. Cloud security operations. Okay. What are the activities? What are the tools? What are the procedures? What are the teams which are responsible for maintaining the security of cloud environments? Okay. When we're talking about responsible, we are not basically just mentioning teams responsible, basically saying activities responsible for maintaining the security of cloud environments, tools responsible, procedures responsible, teams responsible. So don't just cling to only the teams. Okay. And we also looked at some of the activities. Let me basically say operations and incident response. And of course, what are some of these activities? Continuous monitoring, we did that. We did, of course, the best practices in continuous monitoring. We also checked on that. Looked at some of types of the ideas, also some types, of course, of the CM solutions, that is. And then we also looked at the incident response plan, the IRP, how it should be, and of course, different phases of incident response. Okay, also looked at best practices, looked at the training and awareness, very, very important, and that's where we stopped yesterday. So today we move now to this next part, second part now. Trickias 12 threads. We always call them trickias. 12 threads. Very dangerous threads. We are going to go through these 12 threads one by one to see what they actually are. Now, the Trickias 12 is a list of the top 12 cloud computing threats identified by the Cloud Security Alliance, that is the CISA, or you can call it CSA or CISA, which is a leading organization in promoting best practices for cloud security. So you can also take your time to be able to research more about CISA, understand actually which kind of organization this or body this is, and of course understand how they operate as well. Very, very important for a cybersecurity professional. First trickiest threat is data breach. Call them data breaches. Maybe, of course, there are many. Okay, so what is a data breach? It is unauthorized access to sensitive data by attackers or even insiders. For example, if you access data that you are not supposed to access, you have breached. That's a data breach because you are not allowed to access it, but you actually accessed and you saw what is there. As much as you didn't pick the data, but you actually saw. For example, if your phone, someone picks your phone and they see messages someone sent you, yet they were not supposed to see them, that is a data breach. You need to know that. So the moment anyone picks your phone and they've gone through, they have told you they have seen something in your phone, that is a data breach and it is not allowed. Okay. An example is, for example, exposed customer data in a misconfigured AWS S3 bucket. If there was maybe the configuration was done where only every individual in the organization can be able to access that bucket and view the data. Of course, that is a misconfiguration, of course. And given that some say when is someone working in a department, in a HR department, and they're seeing some financial records, what they have, etc., etc., what they have, etc. They shouldn't be there. They should be concentrating on checking the employee records, not financial records. And of course, basically that would mean that information has been exposed. Okay. For example, I think I already given that. Let's just move. How do you mitigate that? You encrypt the data so that in case anyone accesses it, they have no way of reading through it unless they have an encryption key. Strong identity and access management, that is IAM. We already talked about that. It has to be very, very strong. Two-factor authentication, you have to implement it. Okay. or let me just say multi-factor authentication. Multi-factor could be so many times, okay? And of course, auditing who has been accessing and why. You can actually audit and be able to see who accessed what, check the logs, who accessed, what time. Of course, you now can ask them, okay, fine, we saw you access this, so what was the intention? Okay, maybe you downloaded this form, or maybe this data set or data insight from this server. So what were you using the data for? Basically, you can also be able to mitigate that problem, the data breach, using that. Then next, and of course, when talk about data encryption, just the same as no, let me just say strong identity and access management. Let me just give you a funny example here. You have a WhatsApp, and sometimes you have to use your biometrics to open the WhatsApp itself. Okay, so even if you just tap on the WhatsApp app on my phone, if you do not have my fingerprint, you are still not going to read the chats. Maybe I mean, you're not going to see any records there. Okay, if I have my records, I mean my fingerprints, the only one I use to open my phone, you can be able to access my photos, for example. Okay, messages, my transaction details, etc. So that's a very strong IAM, that is identity and access management. Let's talk about misconfiguration and inadequate change control. Now, basically, that is incorrectly setting up cloud configurations such as overly permissive identity and access management roles. I've already talked about that, where you just allow anybody, maybe the bucket wasn't well configured, anybody in the organization can be able to access it, and therefore that is misconfiguration and inadequate change control, or expose ports due to human error. Of course, you maybe as an admin, you may be able to forget to configure some parts of the port, and of course that can really lead to a problem. An example is failing to disable unused ports or services. There's some ports that are unused, especially in those cloud environments. You really don't use them. So if you do not disable them, anybody can be able to access and be able to access the system and of course the records. To mitigate, make sure you automate configuration, or you use automated configuration tools, which automatically configure the system, not as an admin configuring manually. Someone configuring manually can actually forget, but if the system is automatic, you are not going to have any problem. We have several tools. We have Terraform, and also using that's Terraform plus policy as a code. We have two, Terraform and policy as a code. I mean, there is that policy use it as a code. Then we also have insufficient identity, credential access, and key management. Weak passwords, very normal. No multi-factor authentication. Like if I see your password, I just capture the password, and of course I can use it because I've seen your username, so I can use it. Improper key rotation, that is, for encryption, you have to ensure that you rotate those decryption keys frequently to be able to confuse any attacker who might be having any intention of attacking your systems. With password, of course, that's basically say some people say their password, I mean the same password all through the systems, or maybe I think maybe someone say using 1234 as a password, or maybe just one word, or even without mixing the special characters, numbers, capital letters, small case letters, etc. So using those weak passwords can actually be very dangerous. And then we also have what we call, I mean, this is an example now. You can hard code credentials, and sorry, an example is hard coded credentials in the source code. For example, we have systems which are created in such a way that when you create an account, they just give you a username and a password. So automatically you're given a hard coded, anyone who creates say an account, they're given a user one, just the same password. Say if the password was 1234, so anyone who creates an account is just given that password and it's the same username. I mean, of course, with a different username, maybe depending on their names. And that is hard coding. Okay, that's hard coding credentials, and that basically will mean that anyone in that case will easily be able to know that, okay, fine, what if someone forgot to change their password? So if my password was hard coded and I just say, oh, I just continue using the same 1234 as a password, and someone just guesses and say, what if this one didn't change? Let me just assume they didn't change, and they actually enter 1234 and they are able to access everything. So they'd be like, wow, we are accessing the system. Okay, so that's an example. Mitigation, use multi-factor authentication in identity and access management roles. Who an admin, which person in which level is able to access what. And of course, you change or you rotate those encryption keys regularly. Okay. Then we also have insecure interfaces and APIs. We have those APIs that are vulnerable, they're not well secured. That they're very prone to attackers. An example is an API that exposes data without authentication. Like the data is just there, so the API is there. Any other, maybe two APIs communicating, or even an application communicating with the API, it just gives the data, no authentication. Okay. How do you do that? Make sure you implement API gateways, input validation. The input has to be validated, whether it is of this person, the exact input, and of course, rate limiting, the rate at which maybe some given information is accessed. Okay, you can also use OAuth 2.0 that is for authentication. Account hijacking. This is where you can gain control of cloud user accounts. Okay, that's an attack gaining control. For example, you are sent an email, it has a phishing script, for example, let me say malware, and then you click on it, you open. Then that session you are holding, for example, right now, it is transferred now to that attacker. So maybe you start seeing your laptop hanging, your desktop hanging. I mean, what is happening? You start restarting, thinking maybe just everything that it's about the laptop, but it's not really about that. The account has been picked away from you, so someone is actually using it now to access some important information. Then they will bring it back to you. So that's an example. Or even exploiting weak passwords. Someone just guessing, maybe they are using 1234, you just enter. So yeah, maybe they say maybe someone you know likes using this password. They just guess it and they exploit. They're able to use your account to access. Then later you're called with the security cyber security team, like, well, why did you access this, why did you do this? You say, no, it's not me, not knowing that somebody else used your credentials to access. So how do you mitigate that? You use multi-factor authentication. You monitor for any anomalous logins, and of course use of strong passwords. We also have insider threats. Malicious people, maybe say employees or even contractors, they could be malicious or even negligent. Someone is leaving their stations, logged in, and not the screen, the desktop is not locked. That's being negligent, but they are not malicious, of course. They do not have any malicious intentions. But we still also have those malicious people, say contractors or even employees. They're just interested in getting the data, maybe getting out, maybe resigning, and of course exposing the company. So those are insider threats. And I think I've already mentioned that. Then we also have least privilege, how to mitigate that. Of course, this example is very, it's just a normal example and can easily understand. How do you mitigate that? Least privileges, privilege access what you use, what you're supposed to use at that time. As much as you have access to a systems X, but in this kind of activity you are supposed to, or maybe you're doing right now, you don't require system X, you need system Y. So you're not going to be given two systems, X and Y. You're only going to be given X. Use it, and once you are done, you get logged out. It's as simple as that. Logging, of course, that is recording all the system activities. We talked about this. and of course behavioral monitoring, trying to monitor how different users access normally and how they are trying now to do. When you see any behavior that really makes no sense, you stop, or maybe you suspend the account. Denial of service, overwhelming systems or applications to disrupt services. Basically, is where, for example, bots are sent, numerous bots by the malware, trying to log into the system to congest it with so many requests until the system gets tired. Just like, for example, you're trying to talk with people in say a crowd of people, and everybody's just trying to say the word and bringing problems to you, mentioning the problems. You not continue because you'll be like, oh, okay, I can't continue from there. You just get tired. So basically, that's an example of a denial of service. You can't continue speaking because you have been denied that you know chance of speaking because everyone is just talking. Okay, that's an example. But I think I've already mentioned that flooding a cloud hosted web app with requests to make it crash. Okay, then we also have mitigation, rate limiting. The rate at which this system is accessed should be limited to 10 accounts at a time. The 11th one will be kicked out and be told to wait. So that is rate limiting. WAF, that is web application firewall. I think we already mentioned that. Web app firewalls, we need to also have them. DDoS, so that is DDoS protection, that is distributed denial of service protection. And an example of that tool used is the AWS Shield. So you can actually mitigate that DOS attack using AWS Shield. If, for example, you're using AWS as your cloud service provider. Data loss, which is accidental or malicious deletion of data. That's self-explanatory. You can accidentally delete your data and you never recover it, or maybe you feel like someone has really given you problems. Maybe you're computing, just go and delete their data. That's being malicious, of course, and that's an example of data loss. For example, if you don't back up your data properly, that is improper backup procedures. If the data is deleted, you cannot even have, you can't back up any. I mean, nothing happens after that. Okay. How do you mitigate that? Regular and automated backups. Okay, every time backup your data. Just in case this gets lost, you still have it. Data encryption, encrypt the data. If, for example, someone has to delete, of course, they have to first decrypt it, then delete. Data loss prevention tools. I think I should have maybe I should have actually given those examples here, and they are actually out there. Maybe you can be able to also access them, and of course be able to go through them and see, maybe just have a look at what they are. That's a good exercise, and for example, for me, I will just advise you to do that as well. I think one, if I'm not wrong, that is commonly used is the digital, call it digital guardian, and we also have there is one which is called, there's one for AI, something like Nightfall AI. Yeah, let me just type it here and say we call it Nightfall with one word AI. Yeah, this was used. Oh, sorry, AI. Yeah. EG. Let me just say EG. EG. Nightfall AI. Cause etc. Okay. So make sure that you implement that. So the third one is insufficient due diligence. Okay. Uh, that is failing to fully understand the security implications of cloud services. Like, you are a company, you are an organization, you have acquired cloud services, but you do not know the implications of securing those applications. It's like buying a car and not knowing how to secure your car. That is insufficient due diligence. Like, you didn't do your due diligence to know that this car can actually be hijacked, yes, but can I be able to track it so that I can install a tracker, something like that. Okay, So that's, it's like trying not maybe you didn't do a research enough on that given product and how you can be able to secure it. An example is not adequately evaluating a cloud provider security controls. For example, you have a cloud provider, you just want to go and buy a car, and then you realize that car has been having, that specific model of the car has been having accidents every time you hear this type of car has an accident. Then you go, because you have money, you just go and buy that car. Okay, that is failing to do due diligence on that given car. Okay, that's insufficient due diligence. How do you mitigate that? Compliance and policy enforcement. Make sure that you comply. Okay, make sure you have a policy and that policy is enforced. Basically, it's like being self-disciplined. Okay, making sure that you say this type of car I cannot buy it. I cannot buy this type of car. Not in whichever way. That's just an example. Then we have abuse and nefarious use of cloud services. That's attackers using cloud resources to host malware, phishing sites, and launch attacks. So it's like, there's so many companies using, say, AWS as an attacker. You also go host in AWS malware, so that in case of anything, you're going to use virtual machines to attack those other virtual machines. Okay, so basically that is it. It's like some thief knows you're living in some place, then they also come and rent next to you as their neighbor. That's exactly how it is. So just in case of they get an opportunity, you have left the door open, they just pop in, pick something, and at night they go and sell it. So basically that is an example. Um, um, and for this case, it's like using compute services for crypto mining. This is very common. This is very rampant nowadays. Crypto mining. Okay. Um, yeah, very common. Then mitigation. Make sure you use behavior analytics. Block non-bad IP or domains. Maybe that's all, those domains, these domains are dangerous. We know them. Make sure they are blocked from your network. Share technology vulnerabilities. You have the same. You have, let me just read it as it is. Weaknesses in cloud providers share technology model components. Okay, if that technology that you're using as you are a user, but the cloud service provider, has that technology, it's normal. It is a shared technology. So one virtual machine can be able to attack the next virtual machine. Of course, they can be able to um, actually compromise everything on the other virtual machine. And then also an example is vulnerability in the hypervisor. We'll be talking about this hypervisor um, so many times. Hypervisor, which could allow one tenant to access another tenant's data. So in that, say in the hypervisor where you have two tenants or three, so one tenant is hosting data here, another one. It's just like in the same room. So you access, one tenant access another tenant's information and they pull it out. Okay, and they maybe use it um, against that given individual or maybe company that has been targeted. Mitigation, make sure you use a trusted cloud service provider, because we have those cloud service providers which are vulnerable. So, or who are vulnerable, they do not really, the security is not really as par. So make sure you use trusted cloud service providers with strong isolation controls. Like if you're there, you are there as you. Nobody should be able to knock on your door. You also apply hypervisor and container security best practices, conduct continuous vulnerability scanning, and enable monitoring and logging for shared resources. All these ones, those are ways you can be able to mitigate shared technology vulnerabilities. Now, talking about shared technologies, basically cloud service being shared. So yeah, there's those vulnerabilities that are there. So you have to really do your due diligence to be able to know which cloud service provider has this and which one doesn't have. Okay. Then we have weak control plane. Okay, which is a poor management of cloud infrastructure components like identity and access management. We have logging and monitoring. Like you don't monitor, you don't have any logins. You can't be able to know who accessed what at what time. I mean, you can't know who is accessing what. Okay, someone is just using their password. It is no multi-factor authentication. So that is a weak control plane. Okay. For example, admin credentials stored in a public GitHub a repository. That's a weak, very weak control plane. How to mitigate? You centralize governance and apply strong IAM controls. Centralized governance. Like you don't need to have these logins and all these securities distributed everywhere. Centralize them, put them one place. Make sure you have standardized and well proper policy on how to be able to access all these systems. Now, the third part we are going to talk about is log management and analysis. You have the logs, like logs are there, how do you manage them? And of course, also the analysis. How do you check through these logs to be able to identify any patterns that are really not normal? Okay, so log management refers to the collection, storage, processing, and analysis of log data. We have talked about log data several times, which are generated by systems or applications or cloud services or even security tools. So like say security tools, security tool 1, 2, 3, 4, one has its own log file, another one security 2, 4 has its own, then other cloud services each has applications that you have, each application has its logs, etc. So anyone who access it, able to know someone accessed here, went to this tab, open this, download this. So that is basically what we call log management. Okay, so log management and analysis are essential for detecting and responding to security incidents in cloud environments. It's also used to prove that an organization complies with regulatory requirements. Yes, very, very important. If an auditing firm comes in, maybe sent by, say, Hyper, to come and check whether you actually comply, they are going to do an audit, and of course, they are going to request for logs. If you have them, they are going to say, okay, fine, you actually comply. If you don't have them, you have a problem with them. Logs help identify attackers, methods, timeline, and impacted data. Yeah, because if you have the logs, you can actually be able to see the method the attackers used, the timeline, the time they attacked. That is, they came in this time, they got out of the system this time. Maybe it was between say 9 to 9:05. You can be able to see the timeline, and of course, you can be able to see the impacted data, which data was downloaded, or maybe which data was changed, etc. Then log management has a life cycle. Let me just say there's a process, but let's use life cycle. First, we have log collection. That's the first life cycle in log management, because you can't manage logs that you don't have. You first have to collect them. Okay, so which involves collecting logs from multiple sources, networks, devices, say servers, applications, and cloud services. There's those tools that are used, or we call them agents. We have FluentD, we have Firebit, AWS CloudWatch agent. All these ones are used to collect logs, or to just collect the logs for the users or even applications, depending on which cloud service provider you're using. We also have log aggregation, that is centralizing logs into one single system to prevent silos. Silos basically means, when we are talking about silos, it's like having groups, like group here, another one there, another one. So we call them silos. Okay. So to prevent silos, you need to centralize the logs, put them, say, in one room. Like in your room, you don't need to have clothes. Maybe you have 5 rooms. You don't need to have clothes in this room. In the other room, you still have clothes. In the other room, I mean, you're having like silos. So when you centralize, basically it means you have brought all the information or the logs into one given point, and you can manage them from there. So that's what we call log aggregation. Okay, there are tools that are used. That's Logstash, AWS CloudWatch Logs, Azure Log Analytics, and of course Elasticsearch. Those are examples of tools which we use for log aggregation. Then we have log storage. So after collecting and aggregating, now you stop. Okay, basically means you store logs securely in a tamper-proof system. Okay, yeah, tamper-proof. Nobody can be able to tamper with those systems, because if they tamper with them, you lose the logs. and use warm, that is write once, read many. Like um, you just go and write one to avoid duplicates and etc. You just write once. Like the system has to write once, not several times, because you can be having the same log that is indicated. Like it's like duplicating the information. Okay, so you read once, write sorry, you write once, then you read many times. You can read, of course, many times as long as you have written once. Okay, that's what we call storage. So the moment you store there, you only store or read, you write it there once, and of course you can access that storage and read as many times as you want. Okay, and that is of course the target. You also need to, during that process, you also need to encrypt the data. When you are storing the data, that is, we call it data traced, has to be encrypted. And of course access controls, who controls it, who access it, and what procedures. Maybe do we have multi-factor authentication? So you also have to implement them in log storage. You also have to apply retention policies, and of course say these logs that have been collected today can stay in these logs for 120 days, and then after that they can automatically delete themselves. That is basically what is there. And of course this one is very common, 7 years policy compliance. For example, in records kept by a company, if you are employed and you leave a company after 7 years, make sure they delete your data. Okay. We also have what we call log analysis. You have to always examine. There's another, of course, life cycle, part of the life process. Let me just one part of the life cycle, log analysis. Examining the logs using tools or queries. You have always to see. You have a strong security policy. You definitely have to be analyzing. Of course, look for anomalies, any patterns, any threat indications, etc. Can actually employ the machine learning algorithms to detect unusual login attempts that might signal a brute force attack. Yeah, that's an example, very, very good example. Then we have alerting and visualization. Okay, that's another one where basically it means after these logs have been collected, stored, etc., analysis is done, you have to also implement alerting and visualization. You need to have alerts just in case anybody is accessing something, maybe any suspicious activity, you are alerted. You can also use visualization. Basically means you come up with dashboards which be able to indicate how many logs have been created. Yesterday there were like 200, today there were 2000. Why? So you actually can be able to check what is happening. So when you have those real-time monitoring reports or dashboards, you can be able to see what is happening with your systems. Okay. An example is Kibana. Okay, and of course we also have these ones. Very important. Alerting and visualization. Dashboard tools. Okay. We also, the last one is compliance and auditing. That's the last life cycle, because you have collected, you have done all the other ones. Very, very important. Okay. So using logs to demonstrate compliance with the industry standards and regulations. Okay. You have to be using them. If you're asked, do you comply? Yes, show us evidence. You show them the logs. So that is a good example. Now, what are some of the best practices for log management in cloud security? One is you have to enable login on all services. You don't leave any service out, because that service could indicate something. It could bring in a sign. So if you forget about that, you don't have its logs, someone may be attacking you, trying to look for loopholes, but you don't know. So do not always rely on defaults. Okay. Use central log aggregation. That's avoid log silos. I think you already talked about that. Secure logs. Make sure you encrypt the logs. Of course, we have collect the logs. Just encrypt them. Even if someone accesses them, they are not able to read what happened. This system did what this time. Only the admins are able to do that. You also have to restrict access. Who is able to access what? Then also use IAM roles. Who is accessing what? Admin, what are you able to access? The other, what? HR, what are you able to access, etc. We also have set alerts for critical events. If maybe login attempts fail several times, we have to have an alert. Okay. You also have to have what we call privilege escalations. Then we also have implementing log retention policies, like how long can you store these logs, okay? Because there is what we call cost. So the moment you store logs for over 10 years, for example, I mean, really, logs that were collected 9 years ago, I mean, do you even need to use them? So they may be eating 20 terabytes of your system, but you really don't need them anyway, you know. So basically, you have to implement log retention policies. After say 7 or 6 years, automatically that information is deleted. Um, then we have monitoring logs continuously every time. These logs are coming in, everything is happening, so you have to be monitored by the professionals, cybersecurity engineers. They have to be checking that every time to make sure that we are safe. Then we also have ensuring compliance. Make sure that you store logs in accordance with the GDPR and HIPAA, etc. Any other, bodies that um, uh, you know are monitoring the use of data. Then we have automating analysis. Make sure you use AI or machine learning. Basically, AI is artificial intelligence, and ML is machine learning for anomaly detection. So you can actually come up, with machine learning or AI systems to detect any anomaly in or even behavior of some systems, or even access, or even those logs, the way they are coming. So the moment you incorporate all these practices as an organization, you can enhance your ability to operate your cloud environment securely. You can actually respond promptly to incidents, and you can mitigate the impact of the top threats, which we have talked about, the 12 of them, to cloud computing. And that marks the end of today's class.